In this particular video, we are going to discuss about risk reduction pyramid as per ISO 13859. This risk reduction model that we are going to discuss shortly is not only applicable for the process industry or machinery industry, but it is applicable for all the industry. Take any model, be it finance, governance, anything. Always risk reduction follows this risk reduction pyramid. The terms or definition can slightly differ, but they always follow the same principle. So this is the risk reduction pyramid. And this model is taken from ISO 13859. So when you are reducing the risk, first thing that you need to keep in mind is whether we can eliminate the risk. Is it possible to eliminate the risk? If yes, first action should be taken to eliminate the risk. Second, is it possible to substitute the same with something else? Then we need to substitute that. If elimination and substitution both are not possible, then we have to go for the engineering controls. If engineering controls is also not effective, or we or through engineering control we did not achieve the required level of risk reduction, then we need to go for administrative control. And the last one is a personal protective equipment. This actually mitigates the severity. So first is elimination. How we will eliminate the hazard? If there is some chemical we are using, right? Can you stop using that chemical? We know that chemical is hazardous. If that chemical falls on your hand, that may burn your hand. So is it possible to eliminate using that chemical itself? If yes, then we should go for that. If not, then look for the substitution. Is it possible to substitute the chemical with a less hazardous one, or which may cause less damage to the human? If yes, we should go for the substitution. If the case is such that elimination is also not possible and substitution is also not possible, you have to have used the chemical. For example, if you take battery industry, which requires acid, right? So we cannot eliminate the use of acid, we cannot substitute the use of the acid. Then what we can do? We can use engineering controls. So the whole acid transportation, pouring of the acid, everything can be done through machines, and there can be kept like some controls to the machine so that whenever there is a overflow of uh, overflow of the acid, it will cut the inlet valve or feeding valves. So that will provide the engineering control. You can also use fencing, guards to isolate the people from the hazard. But maybe doing complete automation is not possible or not feasible, or maybe it is so much costly. So there is some places where human involvement is required. Where human involvement is required, use administrative control, right? Change the way people work, train the people, give them awareness, training about handling the material, how it should be handled, right? And lastly is PPE. Use PPE if you are using acids or handling acids. Wear proper gloves, wear face mask, wear eye protection, wear proper coverall, right? So this will mitigate. So even if the acid spills back on his hand, then hand can be saved by use of the PPE, right? So elimination basically physically remove the hazard, substitution replaces the hazard, engineering control isolate the people from the hazard, administrative control change the way people work, and PPE mitigate the severity of the hazard, right? So that is why, based on this pyramid, ISO 13859-1 basically suggests to take these three steps, and they should be taken in order. First, you need to go with one, after one, go to the two, and then go to the three. First is inherently safe design. Design your machine safely. Don't keep any points or where there is a chance of cutting of hand. Don't use the design like that, right? Second is safeguarding or complementary protective measure. If it is necessary that you need to keep the sharp edges or knives, then safeguard it from the people. No, worker should not be exposed to that sharp edges. So that is the safeguarding or complementary protective measures. There are interlocks whenever people goes in front of the machine. There are the light curtains that may actuate and stop the machine. All these things falls under safeguarding. Also the emergency trip push button. Whenever there is an issue, people can use the emergency push button to stop the machine. That also falls under safeguarding. So this safeguarding or complementary measures are achieved through sensor, control system, and after that there are actuators. One of the example is when uh, through through the safeguarding is the safety mat, right? Whenever people goes very close to the machine or the hazard area and foot falls on the safety mat, then what happens? The machine gets stopped, right? So that the person cannot be injured or the probability of person getting engineered get reduced. Now the last one is information for the use. This is mostly used when the inherent safe design and safeguarding both are not possible. Suppose you have a machine in and that is running for 10 years and, uh, and at this moment you cannot change the design, right? Because you change the design, you change the functionality, and it is very costly also. Safeguarding is also sometimes you need to buy a new PLC, you need to buy all the sensor, installing them, the required space for them is not available on the shop floor. Then what you will do? The last option that you have is information to use. Educate the workers, train them, aware them about the hazard that is present there. Put proper stickers, warning, sirens, all these things that will help the worker to understand the hazard and take immediate action on the hazard. So overall, this is the risk reduction pyramid. That's it applicable to all the industries. And the point number one, two, and three are the basic principles of the risk reduction followed in ISO 13859.